All right, so the first thing I should let you know is that I am recording my lectures. So when I do sit down like this, I will be recording my lectures. I'll be recording what's on my screen, and I'll be recording all that. That's just simply so you have a reference of what goes on in class. Now, there's a couple of big things. How many of you got the email last night that I sent out under announcements? A couple of you. It was... So I post announcements, and hopefully that should post to your email. I'm going to go ahead and test it out right now to make sure that that works. Let's go ahead and see. Test. Hello. Okay. And that should get to, and this should send out an email to all you guys. At least, so and it should be coming from Canvas, so so you might just easily ignore it. But I do send out if I need to send an email to the entire class, I'll post an announcement here. Just basically check. So hopefully, just did it go through? Yeah. So yeah, Canvas should be and it should be sending it to your TU email account. That should work out just fine. So I sent out an email last night, and hopefully I've been able to adequately explain what's going on in this class, which is that I'm going to be trying something different, and you'll have to bear with me at least for the first couple of weeks, but hopefully it should work out just fine. The big administrative note for this course before I start going into the syllabus is that for the most part this course is going to be flipped. And that's my objective for it. It may fall completely flat, and we may revert to traditional lectures. But my objective starting out here is that I'm going to try to flip as many of these lectures as possible. This is and I'll explain what that is in just a second. But part of the reason is because I'm teaching 3 of these, and doing the same lecture 3 times is really boring. But also because I've tried out flipped lectures in my last semester. I did a couple of sections of 1068 flipped, and a couple in 2168 that were flipped, and the results were generally positive. All right, so what does that mean to flip the lecture? So the idea is that the time basically that this time in lecture is actually kind of poorly spent. Your attention span is about what, 15 minutes, right? Give or take. I mean, that's about what mine's not that big, so once the first 15 minutes are up, it's easy to get very bored in class. And then you have to really struggle to try to pay attention. Now, instead, a lot of times, it would be better if, you could do the classwork in class. The homework in class so that you can ask me here, right? And that would be a much better use of the time. So the premise is that I'm going to be pre-recording a bunch of lectures. So each week you're responsible for watching about 2 to 3 hours of video. Okay? About 2 to 3 hours of video. About as much time as you would spend in class listening to me drone on. Okay? And then this time spent in class is time spent basically taking pretty much, there'll be basically 10 minutes of review, answering questions about anything that was ambiguous or was terribly done in the video. So basically addressing your questions about the content. Maybe 10 minutes for a quiz, and then the remaining hour is spent basically working on homework, on the homework you would normally get. The end result is that hopefully most of your homework time is spent watching videos, and you don't have to spend too much time outside of class working on homework. And I'm also here able to answer questions in person rather than having to respond to your weird questions via email, right? And you're never really sure how much or what details to put in. So the idea is that this shouldn't be any more work. The when you do what work is just changed around. So I upload all my lectures on YouTube. I've already posted some videos. I did not expect any of you to watch it, by the way, already, because that would be kind of insane. Because most of you don't even know that this was going to be a thing that happened. But I had a link over here. right? So under pages, this is where most of the content you'll find. This one is a link to a single video done by the YouTube channel Crash Course, which I thought was a very good 10-minute overview of basically the entire course, or most of it. So if you want to get like a preview of all the content in the course, you can watch this 10-minute video. Here, this is a link to all the code we have on GitHub. And you just need to, and it'll be kept in the destruct folder, okay? Fall 2017 and spring 2018, that's pretty self-explanatory. That's code from last semester. But I'll be putting each of the content in here, so all the code I do online or in class, it will go in here, and you'll be able to find it. All right? The third link is lectures, okay? And it just isn't necessarily, obvious the first time you check it, so I put down some instructions. But first off, below, I've got basically all the coursework that I did from last semester. I don't need to do that. So all the stuff that from last semester, so both the evening courses and the Monday, Wednesday, which were slightly different. And then all the lectures I've done so far are here in a playlist. So far there are 7 videos. That sounds like a lot, but they're about 10 to 15 minutes long a piece. One of them is like 3 minutes long, so they vary in length. That way it's easy to to watch a bit, digest the content, and then go on. If there are recording problems, please let me know because at most it's then 10 minutes of work for me to re-record it. So, but I've gone over some. But basically, you can click over here, right? You can click this over here to be brought to the playlist, or you can just click this and find the video you need to watch over here.
I'm Professor Rosen, and this is
anything that we do in class will also get uploaded here. Just simply for to make that easy to read. So, okay. So everybody kind of understand that and the objective of the class. That obviously for the first class it's going to be a bit different. So, because you had no idea you were supposed to watch stuff, right? So, all right. So let's go ahead and just do the classical going over the syllabus. Now, I do expect you all to read the syllabus, but so I'm going to hit the important points. So first off, we're going to, this is a course basically on how we organize data and how we can organize data to address specific problems, right? Because how you organize data really impacts how you can access it, how you can modify it, and how you can use it to solve a particular problem. All right, so the first 2 topics we'll go over are generics and inheritance. There's already videos over for inheritance, and we'll be picking up generics as we do array lists, which is a feature to the Java programming language, which is also available in other languages. The easiest way to explain it is rather than having a list of stuff, you can say it's a list of integers or a list of doubles or a list of strings. And if it's not a string, it can't go in the list of strings. If it's not a double, it can't go into a list of doubles. It's a way of putting restrictions on what can go into your what you can go into a collection of items. As a result, when you try to get when you access it, you can assume, oh, there's strings in this list, so I can assume this is that everything in here is a string, and I can just treat it like that. We'll go over array lists, time complexity, linked lists, which is generally, and generics because they look complicated. They're really not, but because they look complicated and weird, that's generally one stumbling block for students. They're not nearly as hard as they look. And linked lists, because you have to remember how memory locations work in Java, that's generally the other stumbling block. But neither of them are actually really that hard. This one's better explained if you just draw it, and this one, again, it's just looks complicated, but it's really not. And that's a commonly recurring theme in this. The assignments will look very complicated. They're really not. They're actually easier than they look, generally speaking. The stacks, then we'll go on to stacks and queues. These topics will probably take the first 4 to 5 weeks, and your first exam will be on this content. Your first exam will be about 5 weeks in. Your second exam will be about 10 weeks in. So week 5 and 6 will be your first exam. Week a 10 or 11 will be your second exam. Okay. Once we do linked lists, because we use what we've already learned to build stacks and queues, it's going to be really easy to build stacks and queues after that. Then we'll learn about recursion, we start getting really fun assignments around week 4. At week 5, I think I start giving you a maze assignment, and then we start just solving a lot of puzzles starting here. Trees will be fun. We'll also learn about heaps and Huffman trees. We'll be learning basically how do you compress data, right? How do you make files smaller, right? How can you take a bunch of data and make it smaller so you can send it out in a much more, better package. Then we're going to go and diverge and learn about sorting algorithms, hash tables, and graphs. So, and again, the warning about things being flipped. So time and place, I have to put this in here, even though you found it, right? So that's kind of irrelevant. Please attend the lab, by the way, in your schedule, right? Because there's only so many seats, right, in the actual lab. So if you need a different lab section, just swap around, swap to a different section of this class. You'll be learning the same content. All right, prereqs, you need to have a C in both 1166 and 1068. So we assume that you know how to use Java in this course. If for some reason you somehow got through and you know C but not Java, please speak to me because, there's actually resources that we can get you up and running really quickly. That shouldn't be anybody, but just in case it happened, let me know. You may not be prepared if you only have a C in 2168. If you're still having trouble with the basics, then you'll have a bit of an issue here. So the textbook is Data Structures, the Abstraction and Design Using Java 3rd edition. The 2nd edition is perfectly fine, by the way. This corrects some small errors I was seeing in the 2nd edition. But the 3rd edition, new, was less expensive, so I went ahead and upgraded to it, which is weird. You can also get the electronic edition. I will be going over all the content in the book. I think I might be skipping I'll try to get to Chapter 3, which is on testing in the new edition. Chapter 3 and 4 in the old edition get merged into Chapter 4 in the new edition, in the newer edition of the textbook. So, and Chapter 9, which is on self-balancing trees, we just skip simply because of time constraints. We just don't have enough time to go over it. But you will know about the content in that. You'll understand the concept of the stuff in that. You just might not. You'll just never have really. You probably won't get the chance to implement them. My office hours. So my office hours are shortly after this class. I'm in Circ 349. My office hours are Monday, Wednesday from 2:15 to 3:15. You do not need any appointment to come and see me during that time. No need to send me an email to let me know that you're coming. Just go ahead. I'm there. Go ahead and walk in. If you need to meet me outside this time, I will make time for you. I will make time to meet you. Okay? Just send me an email. And if you have trouble getting to campus because you have a long commute or something, that happens sometimes, we will be able to meet via WebEx or Skype. So we can do a video chat and then you can screen share, and WebEx allows me to take control of your screen and make some small adjustments to your code if I need to. The TA situation is a bit foobar at the moment. I think I know who my TAs are, and I've got them listed here. I still have to get their office hours and office location. But notice that I didn't put down any specific section for them. That's because as far as just for giving you greater resources, you can go and speak to any of the TAs for this class, right? Even the one who's not, even though they may not be your section's TA, they may not be the one in your lab, you can go to them for anything you need. Okay, even if they're not your section's TA. Okay? All right, so attendance, please do your best to attend both the lectures and the lab, especially since there will be quizzes in the labs. Quizzes make up about 10% of the grade here. You will get free points just for taking the quiz, so they do have a component to them. If you do enter late, don't make a big deal about it, okay? If you're ill, just don't come. Just send me an email saying you're sick, and that's that, okay? There's no need to spread germs. I've got a toddler at home, and I don't want to get him sick, so, just send me an email. That's it. We'll be adults about this. I'll trust that you're actually sick. I don't need a doctor's note. If you're like if you're missing an exam, I'll most likely take your word for it. But but for lectures, just let me know if you're sick. And okay, that's fine. Don't copy other people's work. If you find something online and it's not something really you feel like you can change or adapt to make your own, worst case scenario, cite it, because then you're citing your work. Worst case scenario, I'll just yell at you to do it yourself. But that's not plagiarism if you cite it. So, right? You will be working with others, okay, and creating your solutions. That's not cheating, right? Saying, hey, can I take a look at your solution, right? And then just changing the name on the submission file and submitting it as your own. That's cheating. Don't do that. So here's the big thing you should know. So I've heard basically that computer science has a higher rate of plagiarism than other subjects. Okay? I don't believe this. I believe that computer science is the domain has under it the subdomain of pattern recognition, and computer scientists just happen to be better at detecting plagiarism than in other classes, because that's what we do. We can literally write programs to do it. I could literally give that as an assignment in this class, and that would be something you are capable of doing once you get through halfway through this class, writing a plagiarism detector. So just keep that in mind. So don't plagiarize. It gets ugly. I don't like having to deal with it. If you have a disability and you need some accommodation, please just let me know. Schedule it through DRS. Right, go through all the official channels for that, and I will work with you to make sure you get whatever you need. All right. So grading. So typically, there's generally a slight curve at the end of the class, but generally you need above a 70 to pass the class. This generally works out because of the way the homeworks work. The homeworks and the quizzes provide a pretty nice buffer against any drops in quizzes. Drops again, in your grade due to the exam. But generally, what happens is that the A's are like 88 and above. It really just depends on how everybody performs, and the B's might be like 77 and above, right? So that's what gets adjusted for the curve. The ranges for A's and B's. I never also do it the other way, that only 92s and above get an A, right? If you get a 90 and if you have a 90, you're guaranteed an A, right? And I'm not a jerk like, oh, you only got a 89.5, so I guess that's a B. No, that's in the A range. Okay. There will be extra credit opportunities available on exams and assignments. They will help a bit. So right now, this is tentative, and this is the way I'd like it. Your labs and assignments, so the stuff you do inside class, labs and assignments, by the way, are kind of the same thing. Labs, they're just more of what we'll be doing in lecture, which is time to work on the homework. Okay? Quizzes, labs are time to work on exercises. Labs and assignments are the same thing. Quizzes, which are think of them as mini, really shortly timed assignments, right? They'll be no more than 10 minutes in length. Now, the big thing is that they will, because I've got a lot of students and I hate grading, I'm going to let the computer do the grading. So they'll be done online on Canvas. Typically, this means you will write very little code. The closest you'll come to coding on those is actually something called a Parsons puzzle, where you will have to where you'll have drop-down menus and you have to arrange the program, right, the lines of the program in the correct order. And there will be maybe 5 lines of code or 10 lines of code, but there will be 7 or 12 possibilities, right? So some of those might be, and then it just grades accordingly. So then we'll also have timed labs, which I know some of you in 1068 did not like that, but the 2168 students actually thought it was fine because the 2168 students had a bit more time in the timed lab last semester. So that's there will be about 3 of those. They're like mini exams. So if there's 3 of them and they're worth 10%, you can think of them as basically each being 3% of your grade. They're a good check to see how you're doing. They're not too, so if you fail one, it's not too big of a deal, but, do well on them. And also I've been the general thing I learned from last semester was that to tweak down the difficulty. Now these, unlike exams, will be done on the computer and you will be submitting them online, right? So make sure that you know how to that your computer will work and your laptop will work, okay? Exams, exam 1 and 2 are about 15% of the grade, and then your final is 25% of the grade, right? So it's pretty heavily weighted for the final exam. The final exam has been notoriously difficult in the past, but I don't necessarily think it's because the final is difficult. I think just that final exam season is difficult, right? Because you've got a bunch of stuff to study for. All right. So the big thing for assignments is that turning in assignments and your labs is a two-part process. First, you submit it online on Canvas. That gives you that lets us know it's not late, okay? That lets us know you have a time to show that you've submitted it on time or however late you have submitted it, right? And then the next part of it is coming to us and demoing your code. So coming to me or a TA and demoing your code, and we're going to see how it works, right? And you'll have to explain some aspect of the code or walk through it or maybe diagram it if that helps you explain your code. But this is just simply a way to make sure that you understand the code you wrote. This will be very apparent for the first assignment why I like this. This also means that you pretty much get instant feedback on your grade. You'll know. So what happens if you're terrible at explaining it? I'll tell you to come back and explain it again. You really won't be graded on your explanation. You just need to be able to explain it. And part of that is because it is utterly nerve-wracking to go up to somebody else whose job is literally judging you and having them and then explaining what you spent hours on, right? It is kind of nerve-wracking. And if you're nervous, I'm not going to think you're stupid. I'm just going to think you're nervous and that it's just nerve-wracking to, explain your code to your professor or your TA, okay? Big thing about this is that your code has to compile. Make sure your code compiles. If you're having difficulty getting your code to compile, right, follow this checklist. Right, so this just explains that. Late policy, I have a pretty lenient late policy. Basically, it's 5% off, not 5 points, but 5% off per day, meaning the first day it's late, it's 95, second day late, it's a 90.25. Okay, and then it's an exponential decay. That means that assignments are always worth something. And generally, if it's more than 10 days late, you need to explain why that's late. But there will always be a chance to turn in stuff for credit. Okay, exams. Do well on them, study for them. I will provide a study guide for them. I do provide a practice exam, and those practice exams are really good because what I do is I make twice as many questions as I need and put half of them in a practice exam and put the other half in the actual exam. So that means if you can do well in my practice, you can do well in my exam. Okay. Final exams. Oh, this has to be changed because it's talking about May. I didn't put the right dates in. The right dates are anyway on this semester calendar. I'm not really sure why I have to put those in. That just simply seems like an easy way to make a mistake, which I've done. So also there's this weird thing about student rights and responsibilities. You should probably read it. You actually have rights. So all right. And then I have a list of things you should do. Like ask questions and do homework, right? Ask questions in class if you don't understand anything. All right, so I've spent about a half an hour droning on. So with that said, right, I've done the previous lectures. So let's go ahead and get started on our first homework. So the first thing you'll need to do is split up into pairs. So go ahead.